Welcome back, students. In the last lecture, we started talking about multi-threaded applications, and we looked back at our progress bar application, and we could see the limitations of using that process events method of QApplication class to keep our user interface responsive. And in this lecture, we're going to jump right in and we're going to run this processing loop that we simulate using the sleep method in a separate thread, so it doesn't interfere with the user interface at all. But before we do that, I'm going to change something in our processing loop. Since now each execution of the loop takes 2 seconds, I don't want to let it run 100 times because that's 200 seconds. That's over 3 minutes, and nobody has time for that. So I'm going to change our range function. So we start at 20 and goes to 101 with a step of 20. And so this loop now is just going to execute 5 times, but it's going to start at 20 and go up by 20 to 100. And so we're still going to have a progress bar ranging from 0 to 100, but it's just going to be 5 executions of the loop. So let's take a quick look at what that looks like. So we'll hit start. After 2 seconds, we go 20, then another 2 seconds, 40, 60, 80, 100, and we're done. So the same thing still only takes 10 seconds, but it's 5 executions of the loop to take 10 seconds instead of 100 executions of the loop. Now in the last lecture we said that in order to implement QThread as a background processing operation, we have to create a worker class that's a subclass of QThread. And I said that this is the same thing even though we haven't talked about it necessarily with that terminology. And that's all we're doing up here is we're creating a new class called Dialog Main that's a subclass of QDialog. And then we're overriding this constructor method for the QDialog class and adding our own custom code. And so when I say we're going to create a worker class that's a subclass of QThread, all we have to do is create a new class. We'll call that class worker thread, and that's a subclass of QThread. And I see QThread is underscored in red, which means we have to import the Qt core module from PyQt5 because the QThread class is defined in that module. And we're not going to override the constructor method for QThread like we did for QDialog because there's nothing that we have to add to that constructor method, so we'll just use the standard QThread constructor method when we create an instance of the worker thread class. But we are going to override this run method. And I said this is where our processing is going to take place. So all I'm going to do is copy our processing loop and paste it into this run thread down here. And then instead of running our process when we click the start button, we're going to create an instance of the worker thread. We'll name that instance worker, and we'll call the worker thread constructor method. And then all we have to do is call that instance's start method. And it'll start running this process in a separate thread. Now, there's one more thing that we have to do, and that is that we can't update the progress bar like this because we're calling a method of an object that was created in our main application thread. So we can't call the progress bar, and we can't call the application's process events either. So all this process is doing, it's every 2 seconds it's going to print out a multiple of 20 from 20 to 100. But we can still print out to the console, and that's how we're going to know that something's actually happening in this case. We'll change that in a bit. So now I'm going to start. We can see something's happening. Numbers are printing to the console, but it's not interfering with our user interface. And we just got to 100, and so our process finished, but in our user interface we have no idea what was happening. And that's kind of a problem. But we did say that the QThread class has a finished signal, and we can catch that signal in our main application just like any other signal. So we're going to look for the worker's finished signal and connect it to a custom slot. And we'll call that custom slot worker underscore finished. And so this is just like we've done many times throughout this course. We're just catching a signal, and as I said, signals are the way that we can communicate between threads. It's the only way that we can communicate between threads. And so let's create that custom slot worker finished, and all we're going to do here is pop up a Q message box that says, oh, let's just say worker thread complete. And we don't have to do anything in our worker thread because that finished signal is already part of QThread, which we've subclassed. So let's run this. Now I'll start my process. I can see in the console that it's running. I can use my interface, but now when we get to 100, we get our message box that says worker thread complete. So that's working. Now at least we get some feedback that the worker thread's done. And maybe that's all you need. For instance, if the worker thread is updating a database or something like that in the background, and maybe you don't need to have any information passed to it or anything like that. But it would be nice if the progress bar was being updated. I mean, when I'm running this in PyCharm and I can see the console, so I can see that it's running and we're printing out those numbers from 20 to 100. But if you were running this like a normal application, you can't see the console. And so you don't get any feedback until it's finished. And in this case, it only takes 10 seconds, so maybe that's not a big deal, but maybe it takes a minute or 3 minutes or an hour before it's finished. And so you might want to see some indication in the progress bar that something's actually happening, that a thread's actually still running in the background. So how are we going to do that? Well, we have to communicate our progress back to the main application. And the only way we have to communicate between threads is with signals and slots. And so we have to send a signal that can be picked up by a slot in the main application. And we saw how we have the finished signal is already part of QThread, so we didn't have to do anything for that. But we want to send a signal that has the value in our loop so we can update the progress bar with that. And we don't have a way to do that in QThread by default. So we have to create our own signal. And we'll do that in the class definition above our run method. The name of the signal is going to be update underscore progress. And we create a custom signal by calling the PyQt5 signal constructor method. And we know that we want to pass some information with this signal. And so we have to define the type of information that we're going to send. And it's just going to be an integer value. So that's all it takes to create a custom signal. However, in order for the signal to be picked up in the main application, we have to emit the signal. And so we're going to come down here in our loop and we'll say update underscore progress. Actually, we have to use self update progress, and we'll call the signal's emit method, and we're going to pass it the value of x. So whatever the value of x is, as we're executing this loop, is going to be included in the update progress signal. Then we have to come back to where we created this instance of the worker thread, and we'll catch the signal just like we caught the finished signal, except for now we're catching the update progress signal. And we'll connect that also to a custom slot that we'll call EVT underscore, and let's just call it update underscore progress. And then we have to write this custom slot, and here's where we catch this value that was emitted with the signal. We'll catch it in a variable called val, and then all we have to do here is call the progress bar's set value method and pass it the value that was emitted with the signal, and our progress bar will be updated. So hopefully that makes sense to you. It might be a little bit much to get your head around, but it's actually very simple. We're just defining a custom signal, and then in every execution of the loop, we'll emit that signal with some information, and then up here in our main application thread, we can catch the signal and use it to update the progress bar. So let's run this now. I'll click Start to start the process. You can see the progress bar is updating. I still have full use of my interface, and when it's done, we still get our notification that the worker thread is complete. So that's pretty cool, huh? We're doing the exact same thing. We just copied and pasted, literally copied and pasted our execution loop with only a very small change, and we're running this process in a background thread now, so it doesn't interfere with our user interface. Now, I said that we can do more than just pass a simple integer or a string with a signal. We can pass any kind of Python object that we want. We've seen this a couple times where we saw, for instance, the item double-clicked signal includes a QList widget item. That's a Python object. We get that passed with a signal. So let's think about how we're going to do this. Let's create another signal that we'll call worker_complete. And we create that again by calling the PyQt signal constructor method. And this time we'll pass a dictionary instead of an integer. And then we're going to emit this signal after the process is totally complete. So we'll come here outside of our processing loop and we'll say self worker_complete emit, and then we have to pass it a Python dictionary. So let's just create this dictionary. Say the first key in the dictionary will be emp ID, and that value will be, say, 1, 2, 3, 4. And the second element will have a key of FN for first name and a value of Mike. And the third element will have a key of LName and a value of Miller. And so this is a dictionary that we're going to include when we emit the worker complete signal. And this is being emitted at the same time as the finish signal that's part of QThread. And we caught that finish signal up here. But now, that finish signal is not quite enough because that just tells us that it finished. And we actually want to know that it finished, but we also want it to send some information. And we want to do something with the information that it sent. So instead of responding to the finished signal up here, I'm going to respond to the worker complete signal. We'll still connect it to the same worker finished custom slot. But now, since we're getting some information sent along, we can catch that. In this case, we'll use a variable called EMP for employee because we're getting some employee information. And then I'm just going to modify my message box to include a second line, and that second line is going to have the name that's sent with this dictionary. And so I have my 2 backspace ends to put me on a new line, and then I have 2 placeholders in this message string, and we're going to fill those placeholders with information from our employee dictionary that was returned. And so to say the first one, I want to get whatever value was included in that dictionary in the element that has a key of FN. And for the second, I'll get whatever information in that dictionary has a key of LN for last name. Now, instead of just telling the user that we're finished, we're telling it that we finished and we're sending it back some information. And this information can be quite complex, like a dictionary or any other kind of Python object, really. And then we'll use that information in our worker finished slot. So let's run this. I'm going to click Start. Again, the progress bar is updating. It's not blocking the user interface. After 10 seconds, we'll be done. And here it says worker thread complete. But it also includes some information that was returned from the worker thread. So that's a little bit of a contrived example, but just to stimulate your thinking about what's possible to do in these threads. It's a very useful, very powerful method, and I would encourage you certainly to do some practicing on your own and get used to using it, especially if your applications are doing a lot of processor-intensive computations that can take a while to complete. It really makes your applications much more professional looking. So thanks for listening.